Hello everyone, today we have a presentation about overview of geophysics. Me, I'm Abylay, and my partner Mirai Khaliasov. So what is geophysics? Geophysics is a field that integrates geology, mathematics and physics in order to understand how the earth works. Here we have a picture of an earth and its interior. People who are engaged in geophysics are called geophysicists. Geophysicists study Earth processes through a combination of laboratory experiments, computational and theoretical modeling, remote imaging and direct observation. There is shown how geophysicists are performing work on land. We must remember that geophysicists' work is hard and dangerous, but this slide shows us how these people can face problems occurring while doing works. Geophysicists from Novosibirsk made some selfies right after they had helicopter crash. Exploration geophysics is used to map the subsurface structure of a region to elucidate the underlying structures, spatial distribution of rock units to detect structures such as faults and intrusive rocks, and to search for hydrocarbon reserves. Here we have a list of our geophysical methods. Start with seismic, electrical resistivity, electromagnetic, ground penetrating radar, magnetics and gravity methods.
Seismic survey. The seismic refraction method uses P and S wave energy to map vertical and lateral subsurface changes. A hammer blow or explosive charge generates a shock wave that travels through the ground, which is refracted along material boundaries, and is then received at the surface by sensors. In this illustration you can see how seismic survey works. In the center of this picture there is a vibrator track which generates some waves, and also there are 8 receivers which detect some waves.
The electromagnetic method is based on the induction of electrical currents in subsurface conductors by electromagnetic waves, which are generated on the surface. Transmitter loop generates an electromagnetic wave that propagates into the subsurface. As the electromagnetic energy encounters different subsurface materials, eddy currents are induced and secondary electromagnetic fields are generated. This secondary field is then recorded at the surface by a receiver loop. You will have an illustration of how electromagnetic method works. We can see at the left the transmitter well, which transmits our currents, which inducts currents, and the yellow line shows how the currents are induced, and we can see some primary and secondary fields. The receiver loop at the right receives only secondary field responses and encounters it, and subsequent processing is performed at the land. Electrical resistivity methods are used for locating and mapping groundwater sources, natural groundwater flow paths, groundwater contamination and archaeological remnants. These methods measure voltages associated with electrical currents flowing in the ground. From the illustration of Schlumberger's profile, you can show how that groundwater sources or flow paths are located and mapped by our electrical resistivity method. The next method is ground penetrating radar.
The GPR method is a wave propagation technique that transmits and receives electromagnetic waves. GPR for ground imaging is commonly used for mapping underground utilities, karst features such as cavities and voids, soil rock layer thickness, fractures in bedrock, lava tubes, and etc. In this illustration you can see the basic principle of GPR, which is almost similar to seismic survey.
The next method is magnetic method. Magnetic geophysical method measures distortions in the Earth's magnetic field caused by ferrous materials such as steel, iron, or iron-rich rocks and soil. The magnetic methods can be used for large-scale geology mapping or for detecting buried metallic objects such as underground storage tanks, pipes, utilities, or landfills. In the illustration, geophysicists makes magnetic survey to find buried metallic objects. In our case, these are bombs or mines, etc. Next method is gravity.
Gravity method. Gravity surveys are passive, non-invasive measurements of variation in the Earth's gravitational field. The measurements are sensitive to density contrasts, allowing for detection and delineation of subsurface geology.
A simple gravimeter shown in this picture measures the density variations of underlying rocks, and by this information further decisions are made by geophysicists on the surface.
Thanks for watching.
Goodbye.